In this video, I want to give you an introduction to the factorization for the difference of cubes and the sum of cubes. You'll notice I have two formulas here, and it looks a little bit like difference of squares, except the formula has a bit more to it. So let's look at the difference of cubes first. We have a cubed minus b cubed, saying that we're subtracting two perfect cubes. So the a and the b are what we're cubing, so that's going to go here in this first quantity, a minus b. And then the second quantity, we have this a squared plus ab plus b squared, where we're basically, after we've decided what a and b are, we just put them in this formula and simplify as much as possible. And you'll notice a lot of commonalities between the difference of cubes and the sum of cubes. All the a's and b's are in the exact same places. The only difference are the signs in a couple places. So the difference of cubes, we have minus, plus, plus. And in the sum of cubes, we have plus, minus, plus. So you'll notice the sign of this first quantity just matches here, and the second sign is the opposite, and the last sign is positive in both cases. So let's go ahead and take a look at this example. I'll show you how it works out. So we have x to the sixth plus 27y cubed. Okay, so we're saying this is the sum of two perfect cubes. So we need to ask ourselves, what got cubed in order to give us x to the sixth? And what got cubed to give us 27y cubed? Okay, well, what got cubed to give us x to the sixth? Well, that's x squared, because we have the power of a power property for exponents, which says we're going to multiply these, so 2 times 3 is 6. Also, what got cubed to give us 27? Well, 3. And what got cubed to give us y cubed? Well, just y. So now that we have this x squared and 3y, those are going to be my a and my b respectively, so I can plug them into my formula. So sum of two perfect cubes will look like the a, which is x squared, plus b, which is 3y. Okay, and then we have the rest of this. So a squared. So we're going to square this first one. So x squared squared will be x to the fourth minus ab, so minus the product of these two. So x squared times 3y, we'll just say it's going to be 3x squared y, and then plus b squared, which is the square of this second term. So 3 squared is 9, and y squared is y squared. Okay, so here then is the factorization using the sum of cubes formula. And what I'm going to do, I'm going to take a moment and multiply this back out and show you why this works. Okay, so x squared, let's go ahead and distribute it through these three terms. And we get x to the sixth minus 3x to the fourth y plus 9x squared y squared. Okay, let's go ahead and take this 3y and also distribute them through. So we'll have 3x to the fourth y, it'll be positive, so 3x to the fourth y. And then minus 9x squared y squared. And finally, plus, and it looks like 27y cubed. So what do you see automatically? Well, we have a lot of terms that cancel, and we're left with the x to the sixth and our plus 27y cubed. So you can see that the formula works by canceling out a lot of these terms, and you're just left with your a cubed and your b cubed. So here's the factorization for the first example for the sum of two perfect cubes. Now in this last example that we're going to do the difference of two perfect cubes, except you'll notice these don't exactly look like perfect cubes. But there are some factors here that we can factor out of this expression before we get started. So it looks like a 3 will divide nicely from the numbers, and it looks like an m and an n squared. So after we factor out the greatest common factor, it looks like we'll have 64 m cubed minus 125 n to the ninth. Okay? So ignoring this greatest common factor for a second, we can focus on our difference of cubes right here, and we have our factorization formula at the top here. And of course, the question we're going to ask ourselves first is, what got cubed to give us 64m cubed? And what got cubed to give us 125 n to the ninth? Okay, well, the cubed root of 64 is 4, and the cubed root of m cubed is m. So this 4m will be our a value for our formula. And what's the cubed root of 125? Well, that's 5. And how about the cubed root of n to the 9th? Well, that'll be n cubed. And again, it's that power of a power property of exponents where 3 times 3 makes 9. Okay, so if I know my a value and my b value right here, let's go ahead and plug it into our formula. So it's going to be a minus b, so I'm going to subtract them first. So I'm going to go ahead and put my greatest common factor right here, and then let's go ahead and subtract these two. So 4m minus 5n cubed, again, that's the first quantity. And the last quantity is a squared, so it's the square of this first term, so 16m squared. And then we're going to add, and we're adding the product of these two terms, so 4 times 5 is 20, and then n cubed. And then finally, we're going to add the square of the second term. So the square of this should be 25. And then also we have to square the n, so n to the 6th. So that's what this factorization will look like for this algebraic expression. We took the greatest common factor out first. What was left over was the difference of two perfect cubes. And we were able to factor it using our perfect difference of cubes factorization. So that's kind of a short introduction to our difference and sum of cubes factorizations.